So we have quite a lot of people to get through and contribute. I don't think I've ever moderated a panel of 7 before. But I might start actually with you, Anya, from Aon, talking a little bit maybe about some of the digital technologies, things like the Internet of Things, and what impact they're having on your business and how you think about them, you know, how those technologies are doing things like help balance supply and demand.
E.ON is, just for the, let's say, sake of everybody, is a big utility based in Europe, but we have operations, let's say, in the US and North America. We have 30 million end customers, a very sizable, let's say, power and gas distribution business, and a big utility scale renewables business. And digital plays a very, very important role in our, let's say, transformative agenda of the whole company. And if we think about digitalization and our digital roadmap, we basically always think about 3 things. The first is a better customer and employee experience. So we try to really understand the needs of our customers and also our workforce better and tailor propositions really to their needs. So this is one distinct area of use cases we focus on. Second is clearly process optimization, so improving performance of our operations, be it, let's say, in renewables or customer service centers, etc., via automation and application of leading digital technologies. And the third, let's say, area we focus on is clearly completely new business models enabled by, let's say, the use of data, and which didn't exist before. And talking a little bit about my area of responsibility, which is large-scale renewables, our focus is clearly at the moment very much on performance improvement in operations. Just to give you some examples, we invest into machine learning and artificial intelligence and better analytics to improve our maintenance strategy. So we basically developed our own algorithms to do predictive maintenance rather than just reactive maintenance, to give one example. Another example is we invest into, let's say, smarter algorithms to optimize the wake effects in wind farms, which is very, very a special application, and I can go on and go on and go on. So in a nutshell, we have defined for my area of responsibility a very comprehensive digital roadmap, and we are executing against it. And I think what is key is this, we call it let's say the minimum viable product approach. So doing things fast and agile, and to test, learn, and adapt, because this industry is moving so fast. It's very hard to keep up pace.
Terrific. Well, I think we'll probably come back to you on some of those points as well. But Steve, you've looked at technologies in a very broad sense, well, both deep and broad, I think. So it'd be great to hear from you. You know, what do you think are the technologies that are most relevant, both the immediate technologies and maybe 1 or 2 of the more cutting-edge technologies we've heard about in the last couple of years?
Sure. Oh, thank you very much. It's a pleasure to be on the panel today. The discussion of digitalization is very important for the Cleef University of Science and Technology, which I think many of you may be aware is the new university formed from the recent merger of the Matar Institute, the Petroleum Institute, and the Cleef University of Science, Technology, and Research. When we think about the research agenda, I think it's important to consider what is this digitalization topic, what is this fourth industrial revolution, Industry 4.0. And I think at the highest level, it's really about trying to take this new increasing capability to gather information from people and places and things, the world around us, and then connect that to these repositories of storage that you can retrieve the data from, analyze it, and then gain a situational awareness or a foresight, in a sense, shape the future in front of you. Now, when you take that as a platform for digitalization, I think the number of technologies that we were seeing in the past, many people would talk about big data tools and techniques, which is extraordinarily important. Given the past few years, the growth in data generation has been just phenomenal. I mean, I've seen IBM talking about 90% of all the world's data generated in the past 2 years. Now we're seeing internet traffic flows around over a zettabyte, which is something on the order of 10 to the 21st power, so it's huge. And so today you see mobile technologies generating these kind of data and the Internet of Things, which extends mobile technologies into now having sensing in different ways, collecting, say, sensors from what we heard about industrial plants, taking that, connecting that with a myriad of technologies that can bring it to a storage repository, do the analytics, and then get the understanding from the data. And I think the IoT alone is something we could talk for an entire session, but I'll talk about some of the more interesting, all interesting technology, but some of the newer technologies you were alluding to that I think current investment is looking at very closely. And one of those, robotics, and I'm not just the robotics in the sense of a remote control, but the autonomous system in the sense of the underwater, the aerial, and the land-based autonomous systems is a huge area of opportunity in the digital space. The second, I'd say there's two in the second sort of cluster. One is virtual reality, and the second is augmented reality. Virtual reality being the immersive experience, which is extraordinarily important for training, for instance, because you're in that environment and you're not seeing anything else around the world around you when you're doing what you're doing there. And then the augmented reality, many people are aware of this. There's now many more companies than Google, but the Google Glasses, where you can start to receive real-time data from these analytics that can be brought to us from some of the sensors and so on and so forth to become more productive and safer in your work environment. The other area that's quite exciting, I don't think you can go to any technology conference now and not hear about blockchain. And so this distributed ledger, where you take out that intermediation of securing the transaction and verifying the transaction between parties, that is an area of huge technology growth. And it's far, far more than just the Bitcoin, as we know. It's something to talk about in some detail. The other areas, the 3D printing now is truly a digital technology because you have a digital file which transforms information into product, and 3D into 4D where there's time dimensions, so now you can have change of product over time based on the environment it's in. And then the last one, technically I'd say, is probably the most important, and one of the most important for the UE, is artificial intelligence. And AI, I think, requires a little bit more thought because it's a big word, but it has a number of different dimensions to it. And the way we think about it in research is AI has a number of techniques which then can be leveraged to do important things which we couldn't do before, and start to get to that level of what I mentioned previously was situational awareness and foresight, which is essentially a measure of intelligence. And so we look at the data mining approach has been used for big data, as well as machine learning and statistics are all relevant to AI. When you look at the most probably discussed area of AI today and machine learning, doesn't just stop there, because machine learning itself has different variants. People look today when you have data which is tagged or you know what it is, you can use supervised learning to train a deeply connected network and tune the strengths of connections so that you can, over time, begin to repeatedly, with new data, understand what your end results should be from the data coming in. You can use this for images and other forms of intelligence. If you don't have the tagged or known data, you can use unsupervised learning techniques, and you can also use techniques they call the reinforcement learning. So it's not necessarily about these large, deep networks. It's about giving a goal you're trying to achieve and having the system learn based on reward or penalty of how it's going to behave. So these are extremely important areas, but they're sort of the technology behind what you want to do, because you take all this machine learning, statistics, and data mining, and so on and so forth, and then what really AI is about is you can start to do things like computer vision, computer hearing or audition, natural language processing, motion and path planning, and these types of things, collaborative filtering, and you can then package those and you have the ability to do things like drive a car autonomously. So it's extraordinarily important, and I'd say, in the disruption comes from having this new platform of tools which you can now start to say they'll gain traction in an area where they have a use case today. Say, let's use the blockchain, the Bitcoin. Sounded weird a couple years ago, but now as the technology's developed because of this first use, it's going mainstream into supply chains, it's going mainstream into energy, so it will be able to disrupt sectors, right? The truly definition of disruption, and all these technologies I talked about, they go through that kind of cycle. And so we're doing this at the university. The whole platform we have under all of our sector research will really be focusing, at least in the digital space, along these core technologies, moving in to try and do things in a new way.
So it's an astonishing range of technologies we've now got to play with. Some of those technologies have been around for many years. I mean, machine learning is a 30 or 40-year-old technology, but it's only recently that you've had the combination of enough processing power.
The processing power and the
to run
evolution
it.
with technology is what
Yeah.
makes this possible. Absolutely agree.
Yeah, terrific. Helene, we've talked a little bit before, and I know you've got some very interesting perspectives. I mean, you come at it, your job is digital, so it'd be great to hear your perspectives on what that means and what's important.
Yeah, so my name is Helene Verbockhaven. I'm a digital doer. I'm managing digital doers, a very exciting job at ENGIE. So ENGIE is involved in the digital transformation because it's really at the heart of the program of decentralization, decarbonization, and had the pleasure to set up a team to accompany the entity all over the world to transform the business thanks to digital. And after 5 quarters, because we count in quarters, in 90 days, every 90 days we try to build a new agenda for the next 90 days. This is really another way of working. It has been very impressive to see how deep digital can impact the way we do our job, our today job in employee, but the way we can manage our assets, but finally the way we can propose value to clients. And of course there is a lot of technology appearing at the same time, and there is a value proposal behind that we need to find for the end users. And adoption of digital will come from the user. And what we observe in other industries is that digital has been able to transform it. So what's going to happen for energy? Is it a risk? Is it an opportunity? What we think is that when we look at the user perspective and think about adoption, what is magic with digital is that we can really answer nearly all the problems of the customers. So what's going to happen is that will come a point that they will come to us, and if we are not able to propose solution, they will not understand. You know that the young generation, when they want to do something, they just look if whether there is an application on the App Store. So we have to think this way. What are the energy consumer expectations now, and how digital can help setting the expectation? And it starts with data. And what you are totally right is that data is at the heart. Data is within digital world. And it's, for example, just putting some smart meters, it's the first step for transforming the customer experience. And of course, you have to open the data. You need to have the good data governance to make this data available for service provider to imagine new services around it. But it starts with the data. So IoT will provide data, smart metering will provide data, but we already have a lot of data in our systems, in our legacy, on our plant historian, on our customer relationship management tools. So we have many, many data. We just have to harvest, investigate in order to fix and answer the question of our clients. So the way we proceed is using design competencies. So in a dream team, you really need to have UX and UI designer in order to propose a journey that make it very brilliant and very easy to adopt. And we think that designers are maybe not very known in our energy sector. We are more engineer, so we like technology, but at the very end it's a human experience. So design is really one of the key focus we did when building the team. And now we are able to provide new solution, new software to our business units in order really for those people on the field to understand what is digital for real on day to day. So just take an example. Recently, well, for those that you know, in France we are having a big program to develop smart metering in power. And last year we had the opportunity to propose to the customer that had those kind of smart meter to follow their consumption and start providing some recommendation on the best way to consume, comparison and benchmark with others and neighbors that is useful to understand how far you are aware. You have the possibility to become and change the way you behave with energy. You need to know what you consume to start changing things.
So very important not to forget the user.
Yes, user is
not
the
just about
center
technology.
of the purpose of our strategy.
Data is really important, but you need governance for data.
Yeah.
And you know, a lot of potential for applications if you get that balance right. Andy, you're in Australia, you're a gentailer, I think is the correct term. So it would be great to think about, you know, as an established business, how do you think about digital technologies or digitization in terms of, you know, transforming an existing business, and also maybe some of the competitive dynamics that creates with newer players springing up around technology.
Yeah, and I'm going to apologize. I'm not a technologist. Like my colleague in the first seat from Eon, I serve customers every day. That's what we do. And the question of, when I think about all the technologies that you heard the speakers talk about before me, I'm going to take those for granted. And what I know it's going to do in my world, it's going to allow us to gather more relevant data more cost effectively. It's going to allow us to process it more quickly, and it's going to allow us to act on it also very, very quickly. The cadence of that change will be what translates into the value that we add to our customers. But our language is very odd because we believe it's going to be people like Andy Vesey and his company AGL doing this. That's a very archaic concept when it comes to all the technology we're talking about. The fact is the organizational structures we have, the business structures we have, are really legacies of a technology paradigm that's long been dead. These are organizations that have only one purpose. It's to translate and make decisions for the benefit of some output. All this technology puts all that power into the hands of the ultimate consumer. And here's where I want to take a very quick bridge as to, we're here in Sustainability Week. So what does digitization have to do with sustainability? Well, sustainability starts with being as efficient as possible and then meeting those needs with the most sustainable resources. When you think about the old value chain, let's take electricity, production and delivery and consumption. This is a business that in its manufacturing plant literally throws out 70% of its raw material, and that's okay. And then in its long-distance transportation of its product to market is okay that 7% of the product disappears, falls off the truck, and then maintains a distribution fleet that's only used 50% of the time. That's because of the information. That's because of statistics. That's because of the way we think about how people consume the product. There was a very interesting piece of work which you can still find on the internet today, and it's with Steve's former association at MIT, Massachusetts Institute of Technology, had an energy lab in the 70s. And two professors wrote a very interesting paper, and I suggest that if you're interested in this topic, read it. It's on the internet. It was called The Homeostatic Control of Electric Systems. It was written to basically talk about time of use pricing and signaling to customers to change their consumption. But it said something very interesting. It said that in the consumption of electricity, the value of the last electron consumed by any individual consumer is different than any other consumer. So there's always the opportunity for arbitrage by end users. If you can have arbitrage on the last incremental electron by all end users, that's the most efficient system. But the technology wasn't there to allow that to happen. And they had a little thing in their article, and it said, but with the advancements in telephony and computational power, this future is not that far away. Well, that future is here today. And when you think about the end users, don't think about the end user anymore. Think about the Internet of Things. Think about every individual smart device in a home engaged in real-time arbitrage with all the digital technology that we heard about, with every other device. Your lighting talks to your television talks to your washing machine talks to your refrigerator, to get the most optimal mix of consumption. Now think about connecting 50 billion devices actively engaged in arbitrage. The most efficient electric system possible. That's where this is heading. That's where the disruption is. And if we really believe that that's the future, what are companies like mine, what are technology providers, what are vendors thinking about in developing? When you think about, we heard about a smart meter, and I would already argue that the smart meter is already obsolete technology, because most of you have your smart meter in your pocket right now. It's your cell phone, your cellular phone. That's your meter. That's what's going to compute. What do you need to have some archaic device sitting on a wall, because that's where it was 50 years ago and it looked different? Why do we think about an aggregate of the load at a meter point? There's technology now that allow you to see to an end-use device and see that load curve, right? Now, I'm in the gentail business. My fundamental business is risk management. It's matching generation with load. I buy load at a meter point, and I buy average load curves to manage risk. Well, what if I decide one day I need more base load, so I'm going to put out a price to buy everybody's individual refrigeration load, or I need to have some intermediate load to match what I have in my portfolio, and I go out with a bid, and I only want to buy lighting, and I only want to buy lighting between 5 p.m. and 8 p.m. That's where this stuff is going. That's how it radically changes the way we go to market, changes our organizations, and change who profits and who gets the value, and it all moves closer and closer to the customer. And the one other link I'll make, and then I'll stop, is when we think about renewable technology and storage technology play into this game, because what you find out is that these grids that are so important to connect all these devices are going to be very regional. And they're going to be very dependent on distribution networks, and to be able to bring sources, whether they are small-scale solar and battery storage, into grids and create mini grids, that's where this is going. The day of large-scale plants is not necessarily over, but the value of small modular generation and storage closer to the point of consumption is where this seems to be headed. So let me stop there. I think those are some of the implications, and those are things for you all to think about.
That's very interesting. It's interesting how the boundaries of the network, as it were, are sort of blurring. So the sort of traditional divisions between transmission, distribution, and where the network actually stops, because it's now, permeating into people's homes and well beyond. I'm going to go slightly out of sequence, actually, because I'd like to ask Dr. Matar, how, from a government perspective, how do you think about these technologies, both in terms of the opportunities and maybe also in terms of some of the risks of applying them? So if you're thinking about it, from a government policymaker or regulatory point of view, what's your view?
Thank you. Actually, we are living in digital times. This time has an effect, different effect on all sectors of our life. And the energy sector is not an exception to this fact. Energy sector, technology and digitalization has changed and reshaped the way we're doing business in the energy sectors. Let me give you an example. We used to have public utility would be the only one who generates electricity. Now, consumer can do that. For example, in UAE now, by the end of 2018, we expect 200 megawatt to be connected to the grid from rooftop. Electricity can move in different parts of between different countries. Again, here in the region, electricity is moving from Kuwait to Oman. If one of the machine, for any reason, stop, all the machine in the Gulf country that will support in the matter of second. The consumer will not realize there is any blackout. Since the introduction of the GCC connection in 2009, it's prevent about 1,300 blackout from the country. The consumer does not realize any of that. Only the people who are sitting behind the control room realize there is a problem in one of the country. In different parts of the world where there is an energy market, consumer could choose. I'm living, for example, in Aachen, could connect electricity in Milan. without this digitalization and technology, that will not be possible. Transport and mobility with the introducing of electric vehicle, start to be there is some sort of connection between your house and your car. You could charge your house, you could generate electricity in your car, store it, and supply your house, and the other way around. So all this digitalization make the way we're doing business in electricity and energy sector is completely changed. But this does not come without risk. We know the risks that involve with digitalization. We know the risks that is involved with the cyber security, and that is both the question, what we need to do to enable us more, to benefit more from the technology, the new technology, which is evolving day and day, and how we could protect our network, our consumer, and our asset from any attack that could damage one of these attacks, whether that attack coming far away or coming from inside. I think this is a matter need to be discussed in an international context. We need, for example, to have some sort of code of conduct where provide some sort of a guideline for each country to be able to benefit more from the technology and to protect themselves more from this cyber attack that could happen between time on time. Thank you.
Thank you very much. Question, you've come at this from a very different perspective because we've been talking primarily about electricity generation up until now, but I think you're looking at how to use some of these technologies in the oil business. So it would be great to hear some of your perspectives of, and maybe some examples of how you've applied them and what sort of impact they're having.
Thank you. I'm heading the technical center in the ADNOC, which is a group of expertise involved in research, development, and innovation. And one of our tasks is really to put a roadmap for digital transformation, capitalizing on all these new technologies to improve mainly efficiency and reducing cost. And of course, assuring HSE, which is very important in an energy or oil company, and integrity of our facilities. ADNOC is a group of company, upstream, downstream, across all the value chain. We are now focusing on the integration of all these group of companies. We have oil producing company, all onshore, offshore. We have gas, processing company. We have refineries. We have petrochemicals. We have also sour gas companies. We have also services and logistics. You can see this big chain or big number of companies as an ADNOC in the corporate. We want to make sure that we have good integration and with good control of manpower, resources, budget, and at the end, our aim is really to drive down cost per barrel, especially in this period of, relatively speaking, low oil prices, even though the oil prices is increasing now. But, if you compare, a few years ago, we were hit so badly, and we are learning from that experience. We want to be always profitable, even if the oil prices goes very, very low level. And digital technologies and digital transformation is one big potential that could help us in ADNOC to manage this cost and manage efficiency. I think some of you know that some of our initiatives we have launched a few months ago as 2 centers for innovation and focusing on digitalization. One is called Panorama, focusing mainly on the surface activities, and one we call it Thamama, which is mainly subsurface center of excellence. These 2 centers work together to manage huge amount of data from subsurface and from surface. This data will have to be, of course, analyzed. We will use all these techniques of big data analytics, predictive analytics, to make sure that we are in control of our facility. Our vision is really to be able to have a full picture of our operations. Actually, if you visit the panorama, it's a huge screen, many meters wide, and you can trace your barrel of oil from the reservoir, through the wells, through your surface facilities, all the way to the loading oil and gas tankers, all the way to our gas processing or refinery. We want to know exactly where our money is spent and how can we maximize profitability from each barrel of oil or cubic feet of gas. So that's our vision. You asked me about examples. I know I will go very fast. For example, we are now having in our new oil fields, they are all digital oil field enabled, i.e. we have the sensors in the wells, like bottom hole gauges. We have temperature in these wells, so we can monitor the pressure and temperature. At the surface also, we have meters, like multi-phase flow meters. They are all digital. We can have this information from subsurface to the surface. And our aim is to have integrated, real-time integrated production optimization. You can only do that if you have the models. If you can model all your system from surface, from the well, and surface facilities, if you have your integrated subsurface model, and you can then say, with this kind of parameters, this kind of information, this is my optimum performance. And then you compare with your actual, and you compare the gaps. If we can just improve our efficiency, let's say by 1%, that's around 30,000 barrels per day. You can see the potential of these data analytics in the profitability of the company. Another quick examples, using semi-automated rigs. Around 50% of our cost goes in drilling of these wells. And the rigs are very expensive, some of them around $100,000 per day. If you can save just one day, that's $100,000. And we want to make sure that the non-productive time is as minimum as possible through this automation and through the right sensor in the drilling, while drilling the wells. We can then optimize the drilling parameters to include this efficiency. Of course, we work with our partners. We work with major companies, including IOCs and service companies, to implement these technologies. We are working also with companies to implement, for example, pattern recognition while processing our seismic. We are working with partners to do smart search, data-driven models, digital twin models. That's nothing but a digital, let's say, a picture of our facilities. If I have my compressors and I have its digital representation, I know its optimum performance, and then I compare with actual, and then I can optimize the parameters, and I can even predict failures. So these are a few examples. I will stop here.
That's great. So a lot of value in that data in terms of optimization and reducing maintenance costs, and also using some of the technologies I think that Steve was talking about earlier, like machine learning, predictive analytics, and so on. You mentioned digital twins, so I'm going to move to Bhanu, because I know you're from GE, and I know GE is very big on digital twins. So not just that, but it would be great to understand your perspective coming at it from a equipment manufacturer, services provider to the industry, your perspective from that as to where can these technologies be applied, what's GE's approach and strategy towards it, and what's the impact of doing that in terms of impact on utilities and oil companies and others?
Thank you. So I'll come to that, but let me put it something in a more simple way. So when we talk today and we see people say that energy sector will get disrupted with new technology, or it will get reimagined. Now, when we look at it, a lot of people come and say, can you make it simple for me? Reimagining, what does it really mean? If you go back like 50, 60, depending on which country you are, you can go back from 40 to say 70 years back. When energy sector was evolving, it was evolving with some very fundamental understanding. One was that the flow of electron would be in one direction. Some people will generate it, some will transmit, and some will use it. Then the second fundamental assumption there was that it has to be built with keeping decade into, or 10-year, 25-year, 30 years. So for example, the power plant was built and the financial models were for 25, 30 years. Same thing for transmission, same thing for the distribution. Once you sign for a utility, most of us signed it for like the lifetime. And then the third one was that the roles and responsibility of each one is well defined, and let's not too much worry about the other. So generation person was making the efficiency, the most efficient generation, and transmission and distribution. Now all these three are getting challenged today. So for example, if you look at, first of all, flow of electron in one direction had been already disrupted. As mentioned, that 200 gigawatt of power will be generated, megawatt, would be generated in UAE by rooftop solar. So electron is not moving in the direction it was thought 25, 30 years. The second one is the role of load balancing. So the most optimum load was supposed to be, and that was supposed to be utilities' work, that they will be responsible to balance the load and also the cost of it. Now that is changing in a big way, and I think Andy was talking about it, that the appliances of future are going to be smart. So for example, your washing machine will have a small device which would look for the best time to start itself. Same thing, your air conditioning. And today also, if you look at the stock market, most of the transactions actually are done by the bots. They're computers. You set it, and the moment they find the opportunity, they go ahead and do the transaction. Imagine the same thing with your refrigerator, your air conditioning. Now what it drives, that the load balancing is no more only the responsibility of the utility, but actually what is consuming the power is actually helping to drive that. Now when we looked at, and also like that it will be built for a long time, let me give you an example of that. So the way Tesla is looking at it is, all this electrical car, every day they get charged at home, they go to the office, in the office they are sitting idle. Why it need to be? Because it's a good source of energy. So let's plug them back to a junction box and they will start powering it. So it was not the power plant which was built for 25 years, but it's almost like on the move power resource. When we look at all these factors, we realized in GE that whichever way it is going to be different than what it is today. So the old has not given up completely, the new has not appeared, we are in the middle. So let's look at it and let's build a business model around it. So a few things we picked up. One was the platform. So we said all these things are going back to the data, ultimately. Because if you look at your refrigerator and if it has to find the best time to run, then it needs to know the cost of the power at that point of time. So we said, okay, let's put a platform, and that's Predix is the platform where you can do it. And then Qasim touched upon the digital twin. Digital twin is a mathematical model, because at the end of the day, for all these, we call it as IoT or the machines to interact with each other, they need to understand what is their most optimal configuration in the given context of where they are operating, whether it is price, efficiency, type of fuel, the type of quality of the power they are getting. And all those need to be simulated very fast. So you're looking at a combination of very smart edge devices. Edge device is something which is sitting next to the machine. And then a very large platform where people can participate. Think about it like Wikipedia. We all contribute, a lot of us contribute, and everyone consumes. So think about the same way the data of tomorrow in energy sector. So for example, today, if you ask most of the consumers, they will not be able to tell you how much really it costs to generate this power. During the peak hour, how much it costs. During offload, how much. No, there is no way for the consumer to know about it. In future, it would start changing, and people will have more information. And that's where we put the platform, which is mainly a data exchange and digital twin platform. So these two things, at least we felt, are going to be fundamental for this reimagining of this sector.
Okay, that's great. I suspect we're almost running out of time, but I'm going to push my... Okay, we are running out of time. So I think the themes that have come up have been very interesting, actually. We've heard a lot about data. We've heard a lot about technology. We've heard about the importance of users and thinking about how those technologies are being applied, and also some very interesting perspectives on from a regulatory policy point of view, and also in terms of, an equipment provider's point of view in terms of, how these technologies can contribute. The only one thing I'd like to ask very quickly is, do any of you fundamentally think this is going to change the nature of the industry in terms of business models? Or are we talking mainly about, incremental changes to an existing business? And we'll have to be very brief, but if any of you got, real perspectives on that. So is this going to be as revolutionary as it was, say, in the telecoms industry, or is it going to be, more gradual and incremental?
I'll start off. I have a comment on that, and I'm sure others will have one as well. This is based on having looked at several industry surveys, so I think it would be probably generalizable to oil and gas and energy. I think the challenge with digitalization and everything I talk about is very exciting for research, but beyond the cost of procuring the technology, developing the technology, there is still a challenge in trying to ensure that there is an organizational culture able to adapt these technologies. When I say the blockchain, when I say AI, I mean, does the senior management that has to invest in these technologies really understand the value to be created? And secondly, if they do want to invest, do they have the workforce that understands how they will use these technologies? Because the digital twins and artificial intelligence, I mean, the reality is today, artificial intelligence and all these things, it's very narrow, it's very specific, and you can't just let it go and do its own thing, and then all of a sudden you get your value creation. So I think there's still a very big human dimension that needs to be brought into this equation to make this transformation happen. And so it will take, it will be getting going very quickly, but I think it'll take time to realize the full value.
Yeah. And Andy?
Yeah, I mean, look, I think the answer, at least from my perspective, and I'm managing my business as if it were true, is that yes, I think it is challenging. I think that if you look at existing businesses, and I'm going to say I'm talking about, for the most part, the electric industry, the production and delivery of electricity to the consumption by end users, is changing. You just have to look at the financial statistics and how much more capital is taken to get less and less return all the time. It's a business that has to change. Now the question is, how will it change? Will it be the incumbents that change it, or will it be new technology companies that sort of restructure the business, that the industrial structure itself will change? And so things like network companies or retailers are terms we don't use anymore. I mean, is there an Uberization of the sector? Maybe, but I actually think it will be. It will not be predictable. It will not be evolutionary. It will be radical, and it will happen much quicker than anybody believes. How long it takes to become the standard, new standard, is a different question, but I think you already see it happening, and if we're not paying attention, you'll be very quickly surprised how it will change the world.
And Annie, you're nodding.
Yeah, I couldn't agree more to what Annie said. I think it will be definitely revolutionary, and we see today already new business models appearing. I mean, of course, process optimization, etc., enabled by digitization is important. But if you think about, let's say the end customer business, if you think about blockchain, this is a reality today. You see those peer-to-peer transactions. It's happening today. Is it already super big? No, it is still, in terms of value pools, small, but if you simply think about the pace of technology development, I think we will see a revolution coming in the next 5 years, which will radically change, at least in, let's say, more mature geographies where you have those traditional kind of energy models as described here by my fellow colleagues. And I think we will see some radical changes, completely new actors being on the scene. And I think in the context of a more decentral energy world, I think it will be radical. And we need to be at the forefront of it. Otherwise, you're losing the right to exist.
So the first chapter may have been renewables in terms of transition. Maybe this is the second chapter or the sequel.
Michael, where it would flip is, very quickly, where it would flip is that today it is an asset incentive industry. So your price of asset and the way you liquidate the cost, it's asset, all about asset. There is a point where the data will become equally valuable. The moment the data side flip, that's where you will see a sudden change in this industry. Now it is creeping towards that asset is becoming less and less important and data is becoming more and more important. When this switch happens, then you will see very different business model, which maybe we are not even articulating today, would emerge.
We are unfortunately out of time. That's been a very interesting discussion. I'd like to thank all the panelists for joining us. And if you wouldn't mind joining me in a round of applause for everyone, I'd be very grateful.
Thank you.